Restoring basic conditions may not really be part of improving your process, but I can guarantee you it'll save you a lot of time if you do include it. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today we will be talking about restoration of basic conditions. So what that means is that basically when something goes wrong or should be better, one of the first things you should be looking at is all of the process knowledge we already have, your basic conditions, which includes things like the machine is just doing what it should be doing, materials are up to spec, operators are operating the machine according to the book. Is this all in place? Do we have the machine at the correct settings? Is it aligned? Are all of the parts working as they should be? Are the materials okay? Those basic conditions in many factories are slipping a bit. It shouldn't be. A world-class factory should not have slipping basic conditions, but you know it happens. So one of the problems that I have with most improvement methods is that they do not include specifically a step on restoration of basic conditions, and they should. So I like to work with improvement methods that do have this step, this sort of basic check of all of the things and how they should be, have it built in explicitly, because it helps you a lot. Now, when you are very far advanced in your performance excellence, your operational excellence journey, you have a good system of managing the 4 M's, right? So managing your basic conditions, your know-how, your process knowledge, and making sure that it really is sustained in practice. Okay, it's probably not all too useful, but for 80+% of companies, I would even say probably 90% of companies, put it in. Now, what do I mean? And when we look at problem solving, the steps: make a team, define the problem, put some temporary countermeasures in place just to contain the problem, do your root cause analysis, and then from that you make countermeasures which you implement, and then you standardize and you sustain those countermeasures so that you eliminate the problem. At no point here are we really looking at, do we still, perform things as we should? Did we have the machine at the correct settings? Was the material batch okay? So this sort of assumes that that was all already checked, which in all honesty, when you're doing a problem-solving team, you sort of also assume. When doing deviation management, the first thing you do is not launch a structured problem-solving team, a root cause problem-solving team. The first thing you do is go through your list of known conditions, right? So this is that combination of what do we know about our process, which are the usual suspects for this type of error. This is a sort of a know-how database. This is process knowledge that you want to build up when you are doing your improvements, your process design, your general performance control. When we see the problem of it's starting to cut into the right side of the product, oh, that is usually linked to that roller, this connector, or that knife not being sharp enough. Let's check those 3 things first before we do anything else, because 80-90% of the time it's one of those 3. That is what you need to build up. It's not in these systems. Now, as I said, for a problem-solving team, a root cause problem-solving team, since you expect one thing to go wrong, I think it's sort of okay. You do take it into account in your root cause analysis. If it was missing one of your basic conditions, you will pick it up here, and then you put countermeasures in place on what is the root cause of this happening. So where are your control systems? But also because problem solving doesn't per se need this. Now, when we look at a very common and much liked improvement method, DMAIC, then we see that defining a problem, measuring and analyzing what happens in the process, how we can improve, stabilize, which things affect the process, and then we're going to change some of those to really improve, to put it at the correct settings with the nice materials, how to maintain the line, how to align it, everything like that. So make some improvements to the process that will improve its performance. And then we put control measures in place, which is roughly the same as standardizing, sustaining. But here we have even less focus on, are there any basic conditions? And that is because the DMAIC method, it is sort of meant for organizations that are slightly further into their journey. So you sort of assume with this method that you have already a good control of your basic conditions in place, and that you're actually making this step change up to a new performance level. But now a pretty common situation. So I've drawn that performance level as a nice straight line, but you know that it's not like that in practice. The performance level will be something like this. So on average, we get to this level. We, especially in the beginning, may not have seen this deviation because it's just within the normal variation. And what we're basically saying is, you know what? We're gonna do a improvement of the average level. We are gonna cut out that whole block. So we're gonna look at what happened here and there and there and there, and we're gonna make sure our process becomes a lot more stable and the average moves up. This type of process improvement, which by the way is very valid. If you see this happening, this is a good way to look, and you can even make it a bit higher. You can say sort of, the top 25%. That is what we can reach. We can reach sort of that level by looking at what causes the bad days in the process. Now, this type of improvement team, I would call it process improvement. You can say it's sort of problem solving also. It is not root cause problem solving. I do not expect when this happens that there is one single root cause that causes all of these. Maybe, but the chances are low. So do not pick a tool that focuses completely on one root cause. But also, in all honesty, this tool, an improvement tool, isn't giving you that great of a start. It'll help, but it would be so much more efficient if you put in a specific step of test the basic conditions. And that step should be roughly here. Because we define the problem, we sort of measure what's going on, but we don't even finish the measurement step. No, we first restore the basic conditions, and when we checked the basic conditions, restored them, and we know that now our process is at least stable again as we once designed it, then we measure if this problem is still a big problem. Because when your overall quality control system, so not your product control system, this is your process control system, basically your real operational management system, is maybe not always 100%. The chance that you simply do not have correct instructions with the correct settings for a machine somewhere, or that at some point things just went a different direction, this new material that sort of requires different settings, different operators do it in different ways, they just sort of tinker with a line and make it work, but they make it work in a different way every week. That part is going to show you. So put it in, make it a DMAIC, and really put in a step to test how your process should run. Do we actually have standard operating procedures? Is this machine actually okay? Go down to the line with a technician, just go and check if things are okay, if the settings are the same as is in your instruction, if you even have instructions, whether all of the shifts do the same. If all of that is okay, then you measure if you still have a problem and where it comes from, and you analyze. Now, in the analysis phase, you will again get into fish bones, you will again get into which factors are important, but at least this time you go in there with a change mindset. So basically, if you want a good improvement way of working, you define your problem, but then you also define how your process should be on the 4Ms. If it really is functioning like that still, restore if not, and then you measure and analyze. Firstly, is it still needed to continue with this pretty involved improvement project? And if it is, which factors in production, in the process, can we change to improve the stability and the performance level even more. Because yes, we want to make that step change, but especially if it's the first or second time you're doing this on any single machine, the chance that just good restoration of basic conditions, stuff that you already knew, just didn't really do in practice, is going to impact your performance to such a level that it's no longer your priority, that you're going to move on to a different area in your operations, that chance is very high. So take this practical advice and restore basic conditions anytime before really diving in to process improvements. If you like this, don't forget to hit that like button. Let me know if this is part of your favorite improvement methodology. For now, I wish you the best of luck restoring the basic conditions to improve your process. And as always, also remember to enjoy the continuous improvement journey.